Okay, in this video we're going to take a look at graphing polynomials. Now so far in Algebra 1 and Algebra 2 you have already graphed polynomials such as linear functions and quadratics in the last chapter. So you've graphed polynomials before, you know how to do it. Today we're going to look at higher order polynomials such as cubics, quartics, and we could even expand on that like quintics and so on and so forth. Okay, but before we can really get into graphing, we have to talk about something called end behavior. And what I mean by end behavior is what's going on with this function at both ends. So essentially we have two ends in our functions. We have when x approaches negative infinity and when x approaches positive infinity, meaning when we move all the way to the left and when we move all the way to the right. And we want to know what is our function doing at these two positions as x moves to the left, as x moves to the right. What's happening to our function? And our function basically has two possibilities. Our function can either go off to infinity or it can end at some point. Well, today we're going to look at the two possibilities of either going to positive infinity or negative infinity. All right? And we have different types of functions, and we're going to call them odd and even. And odd polynomial functions means that their highest order, okay, the highest exponent is an odd number. For instance, f of x equals x. It's a linear function, f of x equals x. The highest exponent of x is 1, and so therefore it is an odd function. So any odd function you can relate to the end behavior of f of x equals x, a linear function. Once again, any odd function you can relate to f of x equals x. So x cubed, x to the fifth, x to the seventh, so on and so forth, will relate the same way. As x approaches positive infinity, so as x gets really big and gets bigger and bigger and we keep going to the right, our function f of x is going to approach positive infinity, meaning it's also going to go up really big and on into infinity. Well, same thing happens when we move to negative infinity. The function moves to negative infinity. Okay, it sounds kind of simple, very intuitive. That's how all odd functions work. Okay, now if we take a look at an odd function that has a negative coefficient, so the difference here, we have f of x is equal to negative x. Well, we still have an odd function here because our highest exponent is 1, and that is odd. But now, because we have that negative, we flip things. As x approaches negative infinity, our function approaches positive infinity. So as x gets really small, okay, or highly negative, okay, as we're getting big in the negative direction, our function is climbing up to positive infinity. Okay, and as we go to positive infinity in the x direction, our function is going to negative infinity. Just the opposite of what we had in the last slide. Well, why is it the opposite? Because we have the negative sign. Okay, so in an odd function, the negative coefficient out front will flip the end behavior. Moving on to even functions. Well, what's the simplest even function that we know of? F of x equals x squared. This is called even because our highest exponent in this case is 2, and so therefore it is an even polynomial function. Well, how does an even function work? As x approaches positive infinity, the function also approaches positive infinity. So take a look at the graph. As we move to the right, our curve is going up and up and up forever. Okay, so it continues to move in the positive direction as x moves in the positive direction, just like an odd function. Now, how this is different, an even function, as well as going to positive infinity when you move to the right, it also goes to positive infinity as x moves to the left. So as you're moving in the negative direction along x, your function is going to positive infinity. Okay, it's still climbing in the positive direction. And notice both arrows pointing up. We have an arrow pointing up When we go in the negative direction on x, we have an arrow pointing up. When we go in the positive direction along x, our function is increasing both cases. So an even function, no matter what direction you go for x, your function itself increases for all even functions. So this works for x to the fourth, x to the sixth, x to the eighth, so on and so forth. Once again, if we have a negative coefficient, it flips. So as we go in the positive direction along x, as we move in the positive direction, the function moves in the negative direction. And as we move in the negative direction along x, our function, our y value here, moves in the negative direction. We have two down arrows. So it's the exact opposite of when we have a positive coefficient. Okay, so those are our two options for end behavior: odd functions, even functions. Now we're going to use that and take a look at this graph, or this chart right here, this summary of our possibilities. So I want you to take a few seconds, pause the video, write this down in your notebook, and then once you have it written down, play the video again and listen to what I have to say. Okay, hopefully you have all of this written down in your notebook, so I'm going to just mention a few things about what this means. Now, the graph of all this, as you know from class, this is just the long form of what a polynomial is. Okay, it could have any number of terms depending on what order it is. All right, you know, a sub n to x to the nth, you know, n could be 4, n could be 1, n could be 16. Can be anything. And this is the standard form that we write our polynomials in. So if our leading coefficient, this a sub n we call the leading coefficient, if that is positive and n is even, then we know that as the function approaches positive infinity, that's going to happen when x approaches negative infinity. It's going to do the same thing as x approaches positive infinity. The function still approaches positive infinity. Once again, if a sub n is positive, meaning our leading coefficient is a positive number, but n is odd, so we have an odd function, well, f of x, as x goes to negative infinity, the function goes to negative infinity. As x goes to positive infinity, the function goes to positive infinity. So another way to look at it is odd functions just do whatever x does. Okay, so if x is going in the negative direction, the function is going in the negative direction. If x is going in the positive direction, the function is going in the positive direction. Okay, so odd just does whatever x does. Even, well, even does its own thing. No matter where x goes, even goes the same way in both directions. All right, and then we have the summary down here for negative coefficients. It's just the opposite of these 2 points. So that's the opposite of that, and that is just the opposite of that, because a sub n is the opposite. Okay, let's use this here. Let's go over 2 quick examples of how to graph. Now, one thing to remember, anytime we graph, no matter what type of function we have, you can always use an XY chart. And that's actually what we're going to do today in graphing this function. To help us, we are going to use an XY chart. So we have our function, and we're going to pick x values in order to find out, well, what's this function going to look like, and plug those in to find our y values. Well, let's first use what we just learned to figure out what type of end behavior we expect to have. So we look at the leading coefficient. So right here, the leading coefficient is 1, and our order of our function is odd. So since it's an odd function with a positive coefficient, as x goes in the positive direction, we expect an arrow to be pointing up at some point. Okay, so we're going to end pointing in the upward direction to the right. And on the left, as x goes in the negative direction, since it's odd, we're going to be pointing down. So expect an arrow pointing up to the right, an arrow pointing down to the left. So let's pick a few points here for x. Let's just go ahead and put in -3, -2, -1, 0, 1, 2, and 3. Okay, I want you to take a couple minutes and plug these numbers in for x to find your y value. Now notice I used a y value here instead of f of x. these are synonymous when we're graphing. Okay, they can be interchangeable because we are on an xy plane. That's why I used y instead of f of x. Okay, so go ahead, take a few moments, plug those in to the function and figure out what y is. Okay, now that you're back, let's just go ahead and talk about these numbers here. If we plug in a -3, we should get -7. If we plug in a -2, we should get 3. If we plug in a -1, we should get 3. 0 is -1. 1 is -3. 2 is a +3. And 3 is a +23. Okay, so we're kind of all over the board here. So let's go ahead and just try to plot these points if we can. Okay, so we're at -3 down to -7 down here. Okay, that's a -4, sorry. Ignore that point. Okay, so -3, -7. All right, well, -2, we're up at 3. -2, all the way up at 3. And then -1, we're also at 3. Okay, so something's going on here. Obviously, we're coming up here, and then we're going to have what we call a turning point that we'll talk about later, right here. And then 0, we're down at -1. 2, oh, sorry, I skipped 1. 1, we're at -3. 2, we're at +3. And then 3, we're at 23. So we're way up here. We don't know what's going on. All right, well, let's go ahead and figure out our end behavior here. We know that at 3, we're way up here at 23. And so we know that this is going to go up like that. And that meets our requirements of the end behavior. Okay, so that makes sense with what we just discussed. Now over here, same thing. We're coming down, and then we're going to continue to come down quickly. All right, so let's go ahead and finish our end behavior there, because as we go in the negative x direction, our function should go in the negative direction. All right, well, we have to look at what's going to happen here. Well, it looks like we have to keep going this way, and then we're going to eventually turn around, come through there. We got to go through this point, and then at some point we turn around and come up to this point. Now, I know you might not understand, well, how do we know where to turn and all that? We're going to get into specific turning points later, but right now what I want you to do is to just connect the dots. Now keep in mind, we don't want jagged edges here connecting these dots, because these polynomial functions will not have jagged straight edges like this, okay? These are not piecewise linear functions, so we have to round off our corners, okay, and go through all these dots. All right, we're going to take a look at one more example. An example of an even function. Now, why is this an even function? Our exponent of the highest term is 4. 4 is an even number. Okay, so what I want you to do, take a look at this. Try to think back to what our end behavior is going to be and make an XY chart in order to graph. So once again, let's go ahead and use -3, -2, -1, 0, 1, 2, and 3. So take a few moments. Think about the end behavior with a negative leading coefficient of an even function and find out what these points are going to be, and then come back and we'll do this together. Okay, welcome back. Hopefully you put in some of these points here for x to find your y values, and not all of these are we going to be able to fit on our graph, so we're just going to plot a couple of them. 3, -3, -21, not going to fit on our graph, so we're just going to leave that there. -2, 0 we can fit. -1, -1 we can fit. 0, 0 we can fit. And then 1, 3 we can fit. And remembering our end behavior, because this is an even function with a negative coefficient, we know that we need to be pointing down in both directions at the end. And so we know that our end behavior is going to be in the negative direction. So this has to be going down in the negative direction, and this has to be going down in the negative direction. Okay, and this line could be in a little more, but if we take a look at this, we're going to come through here and look something like that. All right, take take a second to try some of these, and we'll talk about issues